Hi, my wonderful students. We are now going to be tackling our final two examples of this section, which are the arc length of a circle. So we'll be finding the length of the circle in terms of its circumference. So we're not going to be finding like the degree of the arc. We're going to be finding like if you were to take the part of the arc and flatten it down to a straight segment and we could measure it with a ruler, that's the point of arc length. So you're going to find just normal units, not degrees or anything, things like feet, inches, things like that. Okay, so we're going to find the length of each arc. So let's go back to that wonderful Prezi and learn about the arc length again. So the arc length is the length of the portion of a circle. So it's basically just a part of the circumference. So we're not going to do the whole circumference. We're just going to know about part of the length of the circumference. So this is kind of a recap of what we've been talking about. So this is like the sector. This is a segment, and arc length is just part of the circumference. So we're not going to get the whole circumference, just a portion of it. So we want to know the length of just a certain part of the circle, just one arc in the circle. Alright, so the arc length, we're going to denote with an L for length. Okay, 2 pi r. What is 2 pi r? That's just the circumference of the circle. And the arc length is just dealing with a fraction of the circumference. So we're going to multiply the whole circle, the length of the whole circle, the circumference, by the portion of the circle we're dealing with. So x in this case is going to be the measure of the arc that we're dealing with. And since there's a total of 360 degrees, this will give us the fraction of the circumference we're dealing with. So basically arc length is just an extension on circumference, just like sector area was an extension on the area of a circle. So you're not really learning a brand new formula, just know that arc length is just a part of the circle. So you're figuring out what part of the circle it is. So let's get going. Already pumped up. Okay, so our arc length we denote with an L for length, if you didn't know that. So length equals our circumference, which is 2 pi r. Technically, if you need the diameter, it could be pi d, whatever you want to call it. I'm going to write 2 pi r times the degree of our arc over the total degree of the whole circle. So this is going to be the fraction of the circle that we're dealing with out of our circumference. So we're going to find the circumference and find the fraction of the circumference we're dealing with. All right, let's get going, you guys. So now you're already excited. So we have 2 pi times a radius. What is the radius in the circle? You guys are so smart. The radius is 10 feet. So I'm going to fill in 10 for my radius. And then times the degree of the arc we're looking at, which we're trying to find the length of DC in this picture, which D to the C is this arc right here. So I want to find the length of that arc. And the fraction of the circle we're dealing with is only 90 degrees of the whole circle. So this is 90 degrees out of 360. That's 90 degrees, not 900. Watch yourself. All right, so the length equals 2 pi times 10, which is 20 pi, times 90 over 360. Well, let's reduce down this fraction real quickly. Okay, so if I divide by 10, one of my zeros will cancel out, and there should be a degree symbol. My degrees will also cancel out. So I'm left with 9 over 36. What is the number that divides into 9 and 36? It is 9. So I'm going to divide the numerator and denominator by 9. So 9 divided by 9 is 1, and 36 divided by 9 is 4. So we're dealing with 1/4 of the circle, which the fact that my colors aren't matching is irking me, so I'm going to fix it. Alright, so after that we just multiply, then we're done. Which, since I have a fraction, I'm going to transform 20 pi also into a fraction, which is over 1. And then, how do you multiply with two fractions? You do go straight across. So let's multiply that thing. So the length equals 20 pi times 1, which is 20 pi, over 1 times 4, which is 4. Which 20 over 4 will reduce down to 5. So my length is 5 pi. And since I only have one variable in the mix, technically x is a variable, but I only have one dimension. My one dimension is the radius. So since I only have one variable I'm working with, we're not going to do units squared, we're just going to do units. So one dimension means we raise it to the first power. So this will be 5 pi feet. And that's it, you guys. Holy heavenly hamburger hot dog, right? Alright, so example 9 is pretty much the same thing. So if you got that, you can try example 9 on your own. Nice job, you guys.